Welcome to the Electrical Mission School. In this course, we are going to discuss about the construction of induction motor. Basically, the motor is consisting of two parts. One is the stator, another one is the rotor. The stator is nothing but it is stationary. It is consisting of stator frame. For the stator frame, the stator core is attached. It is laminated body to reduce the eddy current losses as well as hysteresis losses. The outer periphery of the stator core is slotted to house the three-phase stator wire. But here in this diagram, we have shown only the 6 slots. This is the A phase. Nothing but A dash is given the A phase. B dash is given the B phase. C dash is given the C phase. Stator core, stator slots, stator winding. It is a stationary part, hollow cylindrical structure. It has a stator frame which is made up of the cast iron or cast steel. Suppose if you want to reduce the cost of emission, then it is made up of the cast iron. Otherwise, you are going for the cast steel. Also, the laminated stator core, which is made of the silicon steel to reduce the eddy current and hysteresis loss. It also gives the mechanical support to the machine. The outer periphery of the stator core is slotted to house the three-phase stator winding. As rotor. The part which is rotating in nature is nothing but a rotor. It is a cylindrical structure. It is made of the laminated body with a silicon steel or cast iron. Again, if you want to reduce the cost of emission, then you have to go for the cast iron. If the cost is not a primary thing, then you are selecting for the silicon or steel. As per the construction, there are two types of rotors are used practically. One is a spiral case rotor, another one is a step ring rotor. This is the construction of the spiral case rotor. This is a cylindrical body. The outer periphery is slotted to keep the rotor bar and two sides of the rotor. This is one side, this is another side. The two sides of the rotor, these rotor conductors are welded to the copper ring. Suppose if you see only the conductors and copper ring means, then this is the structure. It seems like a case to the spiral, so that we're calling as a spiral case rotor. These rotor bars are made of aluminum. This end ring, generally it is taken as copper to reduce the resistance of a rotor winding. If the resistance is not a matter, then we're going for the aluminum ring. Squirrel case rotor. In this construction, rotor bars are placed in the rotor slot. These rotor bars are short circuited by the copper ring. At two ends of the rotor, it seems like a case to the spiral, so it is a spiral case rotor. Generally, rotor bars made up of aluminum. The slip ring rotor also, the rotor core is cylindrical body. The outer periphery is slotted to keep the three-phase winding, which is similar to the stator winding. So this is the three-phase winding. This is the rotor core. The three-phase winding, which is connected in a star, rotor core is placed on the shaft. On the same shaft, three slip rings are placed. The three slip rings are electrically isolated. The stator winding is connected in a star. So finally, we're getting the three terminals outside. Those three terminals are connected to the slip ring. On the three slip ring, three brushes are resting on it. To the brushes, at the time of starting, we're connecting resistance into the rotor circuit so that the machine has a high starting torque. Once the speed of a motor is increases, then these brushes will be lifted from the slip ring. One metal collar come and touches the three slip rings. Nothing but it is simply making a short circuit. Slip ring rotor. It is a cylindrical laminated body. The outer periphery is slotted as like a stator. They house the three-phase rotor winding, which is connected in a star. The remaining three terminals are connected to step ring. The brushes are resting on the step ring. These are connected to the external resistance at the time of starting to have a high starting torque. As the speed of motor is increases, The external resistance is disconnected. The springs are short circuited by metal collar. Shaft. The rotor core is placed on the shaft. It has a good mechanical strength. It gives a mechanical support to the rotor structure. It is made up of the cast iron. By means of a shaft, we are keeping the rotor within the stator. Comparison of induction motor. Now here we have seen the two types of rotors. One is the squirrel cage rotor, another one is the slip ring rotor. There is no change in the construction of the stator. Suppose if you use the squirrel cage rotor with a stator, then it is nothing but a squirrel cage induction motor. Suppose with a stator, if you use the slip ring rotor, then it is nothing but a slip ring induction motor. These are the different points when you're going to compare the squirrel cage induction motor and slip ring induction motor. Squirrel cage rotor is very simple and rugged construction. It's complex construction, low cost. Slip ring induction motor has a high cost, low starting torque. Slip ring induction motor has a high starting torque because through the slip rings you can add external resistance to the rotor circuit so that the starting torque of the induction motor will be improved. 80% of the induction motors are the squirrel cage induction motor. Only in some special cases where load requires high starting torque, there we are going for the slip ring induction motor. That is 20% of induction motors are the slip ring induction motor. It does not require any maintenance, but it requires a maintenance due to the slip ring. In case slip ring induction motor, the steppings are there. Always it requires some sort of maintenance. In case of squirrel cage induction motor, how many poles the stator winding is designed, the same number of poles also will be induced on the rotor bar. But in case of a slip ring induction motor, the rotor winding also similar to the stator winding. So the rotor winding also should be designed the same number of poles as a stator winding. Suppose if the stator winding is designed for the 4 poles, then the rotor winding also should be designed for the 4. If the stator winding is designed for the 2 poles, then the rotor winding also should be designed for the 2 poles. That is not required in case of a squirrel cage induction. Now we are going to see what are the different parts and materials used for the induction motor. What type of material we are using practically? Stator frame. The stator frame is generally made of the cast iron. So the cost of the machine also will be reduced. If the cost is not constant, then it is made of the steel. Stator core. It is made of the silicon steel. It is laminated body. Why you are making it is a laminated body means to reduce the eddy current losses. We have selected the silicon steel to reduce the hysteresis loss. Stator winding, copper. Rotor box. Generally, we are taking the rotor box as aluminum, but in some cases, we are taking the copper also. Rotor winding. The rotor winding we are using only for slip ring induction motor, so it is generally made of the copper only. Slip ring, phosphorus, bronze. Brushes, carbon. End rings. Generally, end rings are made up with the copper, but some cases we are using with aluminum also to reduce the cost. Shaft, cast iron, because the cast iron has a good mechanical strength. So these are the different parts. Depending upon the cost, we are selecting the type of material for the each part in a induction motor. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel so that I'm always welcome to answer all your questions.